test is Monday. I'm going to post all of the answers this weekend. Everything all worked out so you can see it. But these ones in green, I'm going to do with you today. So when you leave, all the ones in green should be completely done. Not just the answers. Should be completely done. You guys need to do it on your own. All right? I'm not making you do big ideas on the computer, so it gives you all randomized homework. But if we keep submitting the same assignment, 2 and 3 people, then, you know, we'll work it out that way. But you guys need to make sure you understand how to do everything from 7-4, 7-5, 8-2, and 8-3. You will be able to use your calculator. You absolutely will be able to use a calculator, so make sure you have one day of. You cannot borrow during the test or anything like that. You have to have your own. So everybody got your review pulled up? Ready to go? Yes? Okay, here we go. So what do we do with number 1? What do we notice about number 1? We're going to get the same, it has the same denominator already. Perfect. What else do you guys notice? What does this not have? It does not have an equal sign. Some of you got a little confused, I think, on when you needed to solve and when you didn't. If there is an equal sign, you absolutely should have x equals something. Some of you in your quiz just simplified, then didn't finish the problem. So make sure you're doing what the question is asking. If I already have a common denominator, I rewrite my denominator one time, and then I do what with my numerator? What do I do to the numerator? We combine it. So this just becomes x minus 5. Now, guys, think about this. That x and the negative 5 are stuck together. So you absolutely cannot cross anything out. The 5s don't cancel. X squared doesn't cancel. If something is attached with a plus or minus sign, you have to keep them together. So there is your answer right there. That's it. All right, I wrote on here, common denominator, combine the numerator, and simplify. When the denominator is the same, the process is pretty simple. Everybody with me? All right, let's look at number 10. You guys can do 9 tonight and come in with questions. But the first thing I need to do with number 10 is recognize that they do not have the same denominator. So what is the first step in getting the denominators to be the same? What do I have to do? I got to factor. I have to go ahead and break down. So what can I factor x squared minus 5x minus 24 into? So x minus 8 and x plus 3, correct? Okay, now again, I don't have an equal sign, guys, so all I'm doing is just combining. So what would my common denominator be between x minus 8, x plus 3, and x minus 8? X minus 8 and x plus 3. So I look at each fraction independently, individually. My first fraction has both of those denominators, correct? So I just rewrite the numerator. Then I have plus. My second fraction has the x minus 8. What is it missing? The x plus 3. So what you multiply to the bottom, you multiply to the top. So I'm left here with 3 times x plus 3. Do I leave my answer like that? No. First thing I need to do is distribute. So this leaves me with 7 plus 3x plus 9, correct? And then my denominator is x minus 8, x plus 3. Now what can I do? I can combine 7 and 9. What is 7 plus 9? 16. So I have 3x plus 16 over x minus 8 times x plus 3. Take a look and just see if you can simplify it all. Is there a common factor that I can take out of 3 and 16? No. So there you go. There's your answer. Questions? Like denominators, super simple. Unlike denominators, not so bad. You just got to get the denominators to be the same. All right, moving along. What did I write here for a fraction equal to a fraction? What do we do? Cross multiply. When you have a fraction equal to a fraction, you cross multiply. And then what do we need to do with our answer? What do I need to do with my answer, guys? You need to check it. You need to make sure that it's a valid solution. So I'm going to do number 2. You guys do number 1 tonight. I'm going to look at this and say when I cross multiply, because it's one fraction on one side equal to one fraction on the other side, I'm going to write x minus 4 times x minus 3 equals 2 times x minus 1. Do you guys see the equal sign? Yes or no? Yes, so you should get x equals a number. Not just some random fraction that's left over. You should get x equals a number. So let's FOIL this side. X times x is x squared. X times negative 3 is negative 3x. Negative 4 and x is negative 4x. And negative 4 and negative 3 is what? Negative 4 times negative 3 plus 12 equals, then we distribute here. I get 2x minus 2. What kind of a problem is this? What is it? When the highest exponent's a 2, what is this called? It's a quadratic. Good. How many answers am I going to get from this problem? 2. We want to move everything to one side. I'm going to go ahead and combine right here. So I have x squared minus 7x plus 12 equals my 2x minus 2. So let's move the 2x and the negative 2 to the other side. What's the opposite of a positive 2x? A minus 2x. And what's the opposite of a minus 2? Plus 2. So when I do that, I get x squared minus 9x plus 14 equals 0. And now we're going to factor. What are the factors of 14 that multiply to give me 14, but add to give me a negative 9? Negative 7, negative 2. Perfect. So my last step is to solve, is to say what x equals. So I'm going to say here x equals 7, and here x equals 2. Some of you guys got to this part on your quiz, and then just went to the next one. Do I know for sure that those are two valid answers? No, I need to go back and check. I need to take 7 and plug it in here and here. Does my denominator become 0 in either place? No. So then 7's good. What about 2? 2 here and a 2 here. Does my denominator become 0? No. So we're good. Is that always the case? Is it always the case that both answers work? No. There could be a time when one of them doesn't work. Can there be a time when neither of them work? Yes, that's called no solution. So, all right, we good? We good? Okay. For those of you that are following along, paying attention, I greatly appreciate it. All right, let's do number 9. I'm going to go ahead and put this over 1. If you have all different denominators, your first goal is to get a common denominator. And then once you get a common denominator, what do you do with that denominator? They're all the same, so you can just get rid of it. So guys, I'm going to write it over here. What is my common denominator between x minus 5, 1, and x? Tell me, Jordan. X times x minus 5, okay? Just take all the different pieces and put them together. So here's where you guys made some big time mistakes. This first fraction has the x minus 5. What is it missing? The x. So I'm going to multiply that piece by x. What you do to the bottom, you do to the top, and vice versa. The second fraction has a 1. What is it missing? X times x minus 5. So what you do to the bottom, you do to the top. The third fraction has the x. What is it missing? X minus 5 and x minus 5. Now that the denominators are all the same, you don't have to look at them anymore. They're gone. Just use that as a guide to say, okay, I need them all to be the same. So let's rewrite our numerator. It's x times x minus 4 plus 5x times x minus 5 equals 4x times x minus 5. That's just a big algebra problem. That's it. Just a big algebra 1 problem. Find out what each piece has, what it's missing, and now we multiply. So x times x gives me x squared. What's x times 4 going to give you? Or negative 4, I should say. Negative 4x plus, what happens with 5x times x? 5x squared, good. 5x times negative 5 is minus 25x equals 4x times x is 4x squared, and 4x times negative 5 is minus 20x. This problem should look real familiar to the one we just did. What kind of a problem is this? It's a quadratic. My highest exponent is x squared. Combine everything you can on one side to get like terms all together. So I have a 1x squared here and a 5x squared here. What's 1x squared plus 5x squared? 6x squared. It's good. I have a negative 4x and a negative 25x gives me negative 29x equals 4x squared minus 20x. Everybody with? All right, move everything to one side. So what am I going to do? Subtract 4x squared from both sides. I'm going to add 20x to both sides. 6 minus 4 is going to leave me with 2x squared. Negative 29 plus 20 gives me a minus 9x equals what? 0. Perfect. How many answers should I have for this problem? 2. How do I know that? Because it's x squared, okay? So I look and I say, okay, I've got to solve this. First thing we look for when we're solving by factoring is to take out a GCF. Do they have anything in common? I can take out an x, right? If I take out an x, I'm left with 2x minus 9 equals 0. And then I set each piece equal to 0. So I get x equals 0 here. 2x minus 9 equals 0. I'm going to add 9 to both sides. 2x equals 9. So x equals 9 over 2. Is it okay to get a fractional answer? Yeah, especially since you guys are allowed to have calculators, so the numbers might be a little different. But what do I have to do with those two? I have to go way back to the beginning and make sure my denominator does not become 0. So if I plug a 0 in here, 0 minus 5, negative 5, that's fine. What happens when I plug 0 there? My denominator is 0. So is this a valid answer? No. When I plug 9 over 2 in, it does not become 0 in either case, so you're good. Yes, sir. Sure. But you have to check, guys. You have to. All right, let's look at this couple. This is what we did the last few days. Totally different from our lovely combining like terms with our common and uncommon denominators, that sort of a thing. But first, how do I tell if something is arithmetic? It has the common what? Common difference or common ratio? Common difference. Arithmetic. You add the same or subtract the same thing every time. Remember that, guys. Write that down. Arithmetic. You add or subtract the same number every time. When I have a geometric function, what do? You multiply. It's only multiply the same number every time. So let's figure out everything in green. We're going to do those together. How did I get, just think for a minute, how did I get from 9 to 7? Minus 2. Okay, how did I get from 7 to 4? Minus 3. How did I get from 4 to 0? Minus 4. How did I get from 0 to negative 5? Minus 5. Okay, so now you ask yourself the question. Did you add or subtract the same number every single time? No. Did you multiply the same number every single time? Boys, did you multiply the same number every single time? No. So is this arithmetic, geometric, or neither? Neither. Okay, good. How do you explain your reasoning? By showing me this. That's explaining how you got your answer. You're showing me that it's neither adding and subtracting the same thing every time or dividing or multiplying, I'm sorry. So let's look at number 4. How did I get from 1 to 3? Okay, what's another way I could have looked at it? Plus 2. Okay, let's do it that way first. How did I get from 3 to 9? Plus 6. How did I get from 9 to 27? Plus 18. 27 to 81. Plus a lot. All right, are you adding the same number every time? No. Well, let's look at it another way. How could I get from 1 to 3? I could multiply by 3, right? What about from 3 to 9? Times 3. 9 to 27 times 3. 27 to 81 times 3. So what did you do each time here? Multiply. So this is what kind of a sequence? Geometric. Another way you can figure out if it's geometric, remember I told you guys, take one term and divide it by the one in front of it. 9 divided by 3, 3. 27 divided by 9, 3. 81 divided by 27, 3. All right. This one says, write the rule and find the nth term. So if it's arithmetic, this is your formula. If it's geometric, this is your formula. So you're going to need to know the difference of those, guys. We're not giving you those formulas. So how do I get from negative 25 to negative 10? You guys have a calculator. How do I get from negative 25 to negative 10? Adding what? 15. How do I get from negative 10 to 5? Add 15. How do I get from 5 to 20? Add 15. So in this case, we have an arithmetic function because we're adding or subtracting the same number. So I need to know my first term, which is negative 25. And I need to know my common difference, which is positive 15. And now we can just plug it into the formula. The formula is over here. You're not going to get it on the test. You guys have to know that. So when I look at this formula, I say a sub n, that's my rule, is my first term, negative 25, plus n minus 1 times your common difference of 15. And then what do I do with that? I'm going to say, distribute the 15 here. So I have negative 25 plus 15n minus 15. You guys with me? And then can I combine like terms? A sub n equals 15n, and then when I add negative 25 and negative 15, I get negative 40. And there's your rule. Now, how would you go about finding the 20th term? What number do you plug in to find the 20th term? 20. So I say a sub 20 equals 15 times 20 minus 40. And when you do that in your calculator, what do you guys get? Fifteen times 2 is 30, so 15 times 20 is 300, minus 40 is how much? 260. So the 20th term is 260. No, because 15 times 20 is 300. Minus 40 would be 260. All right, look at this one. We have fractions. Sometimes we freak out with fractions. That's okay. Let's go ahead and make everything have a common denominator. If I change this one, negative 3 over 1, to seconds, what would the denominator be? 2. What would I have to multiply the top by? So this would become negative 6. Good. So how did you guys get from negative 6 over 2 to negative 3 over 2 to 0 to positive 3 over 2? What are we doing each time? Plus 3 over 2 each time. Perfect. So again, our two things we need are the first term and your common difference. So my first term was negative what? Negative 3. You could do negative 6 over 2 if you wanted, but I'm just going to leave the whole number. And then your common difference was a positive 3 over 2. So just because you have a fraction, guys, no big deal. It's negative 3, our first term, plus n minus 1 times the common difference. So we're going to distribute negative 3 plus 3 over 2n minus 3 over 2. Everybody agree? I'm going to go ahead and change this negative 3 over 1 to negative 6 over 2, just so it's easier to look at. And then when we combine like terms, my rule is a sub n equals 3 over 2n. And when I combine these two, what do I get? What's negative 6 over 2 minus 3 over 2? Negative 9 over 2. And then if I want to find the 20th term, what's up? If good question. If your problem starts with fractions, you want to have your answer in fractions. If it starts in decimals, then you can have a decimal answer. So if I want to find the 20th term, I plug in 20 for n. Now, I know you guys can simplify here. I'm going to leave it unsimplified. I'm going to say 60 over 2 minus 9 over 2. Why did I do that? Why didn't I just say, well, 2 goes into 20 and then I get 30? How come I left it as 60 over 2? Because the other fraction has a denominator, so I could just see, oh, it's going to have a denominator as well. So 60 minus 9 gives me 51, good, over 2. All right, keep moving. We're good on time? Yeah, we're okay. Say it again. 25 and 1/2? Yeah, that's fine. All right. If I think a sequence is geometric, instead of playing with my calculator and trying to say, oh, I don't know how I multiplied, what did I tell you guys you could do? Take one term and do what? Multiply it by the one in front, or divide by the one in front. What's 6 divided by 3? Okay. Let's take another one. 18 divided by 6. 3, okay. 72 divided by 18. Anything? Anybody? 72 divided by 18? It's 4, okay. Are you getting the same number every time? Are you multiplying by the same number every time? No. Are you adding the same number every time? Can you clearly see that from 3 to 6 is plus 3, but from 6 to 18 is not plus 3? So what kind of a sequence is this? This is a neither. This is neither adding or subtracting the same number every time or multiplying. So it's really important that you guys use your brains and your calculators to figure that out. Look at the next one. I have a whole bunch of fractions. All the denominators are what? They're all the same. They're all 3. So this is easy to figure out. How'd you get from 5 to 10? You added what? 5? 5 over 3. How'd you get from 10 to 20? You added 10. So obviously this is not arithmetic. How could I figure out if this was geometric? I'm going to take one term. I'm going to take 20 over 3 and divide it by the one in front of it. What's 20 over 3? And I'm going to divide it by 10 over 3. How do you divide fractions, guys? 20 over 3 times what? 3 over what? 3 over 10? Right? Keep, change, flip. So your 3's cancel. You have 20 over 10, so your answer is 2, okay? Well, let's take another term. Let's take 40 over 3 and divide it by the one in front of it, 20 over 3. So keep, change, flip. 40 over 3 times 3 over 20. That cancels. I get 40 over 20, which simplifies to 2. What do you think is going to happen when I divide 80 over 3 divided by 40 over 3? My common ratio is going to be 2. So this is geometric. You guys can do that in your calculator and you'll get 2. You don't have to show me by hand. You can do it in your calculator and say, oh, look, it's 2. But you have to be able to work with fractions, guys. All right, so now if we're going to write the nth rule, this is going to be a geometric. What did you multiply to get from 9 to 18? Times 2 each time, right? So your first term is 9. Your common ratio is 2. I wrote over here the geometric formula for you guys, but you need to know it. It's your first term, a sub 1, times your common ratio to the n minus 1. So it's 9 times 2 to the n minus 1. That is the rule. When they say write the rule or the function, that is the rule. And then if you're finding the 7th term, you plug in 7 for what? For n. So this becomes 9 times 2 to the 6th power. What should you evaluate first? 9 times 2 or 2 to the 6th power? 2 to the 6th power. Okay, so when I say 9 times 2 to the 6th power, your calculator will give you 576. Some of you really need to refocus. All right, let's figure out my first term here is 1.2. What is my common ratio? How do I figure that out? Take one of your terms, do this, everybody in your calculator, and divide it by the one in front of it. What's 4.8 divided by negative 2.4? Say it again. Negative 2. How did I know my common ratio was going to be negative when I looked at this? The signs are alternating. I wrote it over here, guys. Alternating signs mean you're multiplying by a negative number. So my common ratio is -2. So my rule is a sub n equals my first term times -2 to the n minus 1. So in a case like this, Jordan, when it starts off with decimals, decimal answers are perfectly fine. So if you're going to find the 7th term, a sub 7 equals 1.2 times -2 to the 7 minus 1. So 1.2 times -2 to the 6th power. Again, what are you gonna do first? What's your calculator gonna do first? -2 to the 6th power. Guys, a negative number raised to an even power is gonna give you what kind of an answer? Positive or negative? Positive. Good. So if your calculator tells you negative, you need to make sure you're putting it in right. But 1.2 times -2 to the 6th power gives you 76.8. You are correct, sir. Good. Good. All right, so let's move on to the last two. I think, I'm not 100% sure, but I think we're going to give you these two formulas. I'll talk to Ms. Carver tomorrow. But for the sum, what the sum means is they're telling you to what number to start plugging in, what number to end plugging in at, and then adding everything together. There's two different formulas, one for arithmetic and one for geometric. The n in both of them is the number of terms. It's going to be the top minus bottom plus 1. A sub 1 is the same for each. It's the first term. You plug in whatever that lower limit is, that gives you the first term. In the arithmetic, you have to also find the last term, so you plug in the last number. And in geometric, you've got to find the common ratio. So you guys need to know the difference between those two. If I look at these, it doesn't tell me which one's arithmetic and which one's geometric. How can I tell the difference? What kind of a function is geometric? What kind of a function is arithmetic? Arithmetic. How are these different? I'm telling you the answer here. This is arithmetic and this one's geometric. One has an exponent. Geometric has the variable in the exponent. Arithmetic is a linear function. We talked about that when we did both of those. Linear means your variables to the first power. So in this case, I'm using this formula. And I know that simply because my variable is up here in the exponent. So I need to find all of the things. I need to find the number of terms. Well, it's top minus bottom. What's the top number you see? 5 minus the bottom one, which is 1 plus 1. So 5 minus 1 plus 1, there's 5 terms. That's what I'm plugging in for n. How do I know what the first term is? I have to plug in the bottom number. So a sub 1 is 2 to the 1 minus 1. What's 1 minus 1? 0. What's 2 to the 0 power? 1. So your first term is 1. That's not always the case. What else do I need to know? Look at your formula. I have the A1. I have the N. What am I missing? The R. What is the R, guys? What's the R? The R is 2. Exactly. It's whatever the exponent is, the base of the exponent. So now you have everything you need. You guys know that your first term is 1. It's 1 minus 2 to the what power? 5th power over 1 minus 2. Now you can simplify as you need to, guys. I have my 1 out in front. I have 1 minus 2 to the 5th power is 32 over negative 1. Still have my 1 out in front. What's 1 minus 32? Negative 31 divided by negative 1. So what is the sum of the first 5 terms of this geometric sequence or series? Positive 31. Negative divided by negative is a positive. Scoot on over here, and then we're done. I need to find my n, the number of numbers. Well, it's top minus bottom plus 1. 5 minus 4 is 1 plus, or 5 minus 4, sorry, 5 minus 1 is 4 plus 1 is 5, okay. My first term, I'm plugging in 1, so it's 2 times 1 minus 1. 2 times 1 is 2. 2 minus 1 is 1. Again, that's not always the case. And then I need to know the last term. What number am I plugging in to find the last term? I'm plugging in the top. The fifth term, I need to find the fifth term. So I'd say 2 times 5 minus 1. So 10 minus 1 is 9. The first term, you plug in the bottom number. The last term, you plug in the top number. And then we're just going to throw it into the formula. So I have n minus 2. Or sorry, n over 2, however you want to say it. What's the number of numbers? I have 5 over 2 times, what's the first term? 1 plus the second term is 9. Okay. So I have 5 over 2 times 10 over 1. What's 5 over 2 times 10 over 1? What's 5 times 10? 50 divided by 2. 25. That's it, guys. What you need to do tonight, you got 4 more minutes. I know I went through that kind of quickly, but I wanted to make sure I got through every single type. You need to do the ones that are not highlighted on here because I already did them for you. If you didn't do them when I was doing them, then you need to do them tonight. I have about 10 people who didn't turn in their homework yesterday. You guys had over an hour and a half in here yesterday in class. There's zero reason that people didn't turn their homework in. You guys have got to use your time effectively. So do the ones that I didn't do for you. Come in tomorrow, ask me questions. I'll give you your quizzes back, and then you guys will have your test on Monday.